Static electricity is always present in your process, and the potential of static electricity buildup to spark explosions, costly fires, property damage and injury to operators is a constant danger. The consequences of this invisible hazard have been seen many times. Yet the static electricity experienced in our daily lives appears to be relatively harmless, if a little unexpected. So what can turn a familiar phenomenon into a serious hazard facing the process industry? Certain conditions need to be met before an electrostatic discharge can cause ignition. The mixture of the solvent vapor and air must be within its explosive range and be present. There must be means of generating the electrostatic charge, and the charge must accumulate to a level with enough energy to initiate an igniting spark. Normally, the spark jumps across a spark gap, but other discharges can occur, such as brush discharges from a charged surface, such as plastic. The risk due to this hazard can be minimized by limiting the accumulation of electrostatic charges to safe values, by controlling the rate of generation, and by providing the means of dissipation, or by eliminating the presence of a flammable vapor-air mixture. This film will deal with the sources of static electricity, good operating practice to minimize charge buildup, effective earthing and bonding, its installation use and testing, and the technical support, codes of practice, and legislation available. SIA and ESIG are providing this overview of the hazards of static electricity and the mitigating measures available to increase awareness among solvent users. Static electricity can be generated in the solvent or on non-conductive surfaces such as plastic drums. Static electricity charge can be generated in solvents by liquid movement such as flow, mixing, pouring, pumping, filtering or agitation operations, where the movement separates electrical charges which may accumulate in the liquid and the containment system, such as pipes, tanks, drums, road tankers, rail cars and ships. If either of the materials is a good insulator, or the plant is isolated from earth, electrostatic charge will accumulate. A good example is liquid flowing through a pipe. Negatively charged electrons move across the boundary between the two bodies and are then unable to return. The charge on the containment system can be dissipated quickly by earthing, but the charge in the liquid remains and is slowly dissipated, depending on the conductivity of the liquid. How quickly the static electricity charge builds up depends on a number of factors. Turbulence of the liquid, the speed and contact of the liquid with its surface area of its surrounding equipment, the presence of impurities, and how quickly the earthing equipment can remove the charge. The amount of charge remaining after a given time depends on the amount generated and the amount dissipated. The time required to ensure the charge dissipates to a safe level is known as the charge relaxation time, which will vary with different solvents. Turbulence experienced in filling operations, caused by large flow rates, splashing, or free-falling liquids, greatly increases the charge accumulation beyond the level generated in pipes. Filters, because of their large surface area, can generate as much as 5,000 times the electrostatic charge generated in a pipe system without filtration. Dispersing operations can be particularly hazardous in view of the extremely high rate of charge generation when particulates are present. High charge rates can also occur when liquids containing non-miscible components are mixed or agitated. With poor conductive liquids, the charge accumulation can cause sparking in the vapor space to an exposed agitator blade in a mixer or to a filling pipe. The electrostatic charge built up in the liquid will dissipate by migrating from the liquid to an earthing point. The rate of dissipation depends on how readily the liquid will conduct electricity. Hydrocarbon solvents have low conductivities and do not readily conduct electricity. The slower the rate of charge generation, the more chance it has to dissipate and avoid reaching the level of charge sufficient to cause an igniting spark. The generation of static electricity cannot be eliminated, but its rate of accumulation should be minimized. although this is not always possible for some end uses of solvents, such as spray applications. In pipes, there are recommended safe maximum velocities for hydrocarbon solvents for various pipe diameters, but there are exceptions for particular solvents and for the presence of contaminants. During filling operations of tanks, road tankers, rail cars, ships, IBCs, drums and cans, splash filling and free fall of flammable liquids should be eliminated to the maximum extent practical by providing diverters to discharge the liquid down the side of the earth container, or by submerging the fill pipe below the liquid level to the bottom of the vessel. Incoming velocity should be reduced until the pipe is below the surface of the liquid. It is particularly important that the velocity of the incoming liquid or liquid being discharged is controlled, so operations such as gravity filling of IBCs from road vehicles should be avoided. Once a filling operation has been completed or a vessel has been mixed, it may be necessary to dip or sample, and a sufficient time should be allowed for the accumulated electrostatic charge to dissipate. The charge relaxation time. Storage tanks can contain a small amount of second phase, for example water, and the relaxation time should be considerably longer than for the pure solvent. Care must be taken when the receiving tank, compartment or container has not been cleaned out and contains flammable vapor, particularly when the next liquid has low conductivity. Experience has shown that installing filters far enough upstream of discharge points to provide a sufficient liquid residence time greater than the specified charge relaxation time of the liquid will avoid problems. This can also be achieved by the installation of a relaxation chamber. For dispersing operations, the conductivity of the liquid should be raised before particulates are added. If possible, conductive solvents should be added first. In some cases, proprietary anti-static agents can be added to reduce the charge accumulation. Typically, only a few parts per million are required. However, these additives can cause problems with formulation and can separate out during bulk transfer operations. Where it is not possible to reduce the buildup of electrostatic charge to a safe level, inert gas blanketing should be considered both for vessels and pipes. Earthing and bonding is a very effective technique for minimizing the likelihood of an ignition from static electricity, and is particularly important where the end user of solvents cannot avoid the generation of static electricity due to the nature of the process, such as a spray application. Earthing establishes a continuous electrical path to Earth and will remove charge rapidly. Conductive equipment is connected to an earthing electrode or to the building earthing system in order to prevent sparking between conductive equipment and earthed structures. A bonding system connects various pieces of conducting equipment together to keep them at the same potential. Static sparking cannot take place between objects that are at the same potential. In potentially flammable locations, all conductive objects electrically isolated from earth by non-conductors, such as non-conducting pipe or hoses, flexible connections, equipment supports, gaskets, should be bonded. Bonding straps and cables and earthing bars should be durable and low resistance, of less than 10 ohms. Portable equipment must be earthed back to the process equipment or common earthing system, using the appropriate flexible cables and clamp. The clamp must make contact with metal surfaces through paint, rust and surface contaminants. Drums and cans must be earthed back to the loading system via earth leads and a special earthing clamp that penetrates the paint coating. Preferably, the earthing clamp is in a separate location to the source of the flammable atmosphere. When decanting from one drum or can to another, ensure the receiving vessel is earthed and the source vessel is bonded to the receiving vessel. When using metal IBCs, the frame around the tank may not be bonded to the tank via an earthing strap, and therefore both frame and tank need to be earthed separately back to the loading system.